In this video, we'll look at a hypergeometric distribution word problem. So the word problem is about a math class. It says there's a math class that has 20 students, and in that class of 20 students, 5 are bilingual. If the class is randomly divided into 4 project teams, so here's the first trick this question does. If you divide into 4 teams, some people are just going to read it quickly and think, oh, there's 4 people on a team. But when you take a bit more time, if there are 20 students split into 4 teams, it's easy math. 20 students split into 4 teams, each team has 5 people. That's just 20 divided by 4. So 5 people on a team, 5 bilingual students, 20 students total. Okay, so that's the situation that we've got. And then the probability they want us to calculate for part A is what's the probability that a team has fewer than 2 bilingual students? So what's the probability that you have fewer than 2 bilingual students? Well, that's just the probability. What's fewer than 2 of having 0 bilingual students? Bilingual. Or the probability of having 1 bilingual student. So all we need to do is calculate the 2 probabilities. Fewer than 2 is just 0 or 1. So what's the probability that you have 0 bilingual students? Well, it's hypergeometric. So we want to have 0 bilingual students, which means from the 5 bilingual students, choose none of them, times the remaining 15 students, you choose all 5 students that you want on your team. That's the total number of ways to pick them. What's the total number of ways you could pick with no restrictions? It's just 20, choose 5. So this fraction here represents the probability of choosing no bilingual students. What about 1 bilingual student? Well, you have 5 to choose from, so choose 1. And then times by the other leftover 15 students. Choose your remaining 4 people for your group for a total of 5. And that's probability, so this is the number of ways to choose them. Out of a total 20 choose 5 ways, you could choose them with no restrictions. So let's calculate that. I think we'll leave it as fraction for now. So 5 choose 0 is easy, that's just 1. You can check on your calculator. 5 choose 0, it's just 1, times 15 choose 5. We get 3003 over, what's 20 choose 5? 15,504. And now on the top here, 5 choose 1, second fraction. 5 choose 1 is just going to be 5 times 15 choose 4. And you get 6,825 over, I already know what 20 choose 5 is, it's just 15,504. When you're adding fractions, don't forget you just add the numerators. Leave the denominator as 1. You get 9,828 over 15,504. That's our probability, but we either have to reduce or I prefer just making a decimal by dividing. And you get a probability of, let's round to 5 decimals this time, 0.63390. So, what's the probability you have fewer than 2 bilingual students? The probability is, you can leave it as a decimal or write it as a percent. Just move the decimal over to 63.39%. So you have a pretty good chance of getting fewer than 2 bilingual students. That's part A. Part B asks what's the expected number of bilingual students on a team. That's just calculating the expected value. For hypergeometric, the expected value formula is just R times A over N. And what's R? The number of trials, or the number of people we pick. We're picking 5 people. And what's A? The number of successes, or the number of people we want, or there are 5 bilingual students we're trying to get. And then how many people are there total? How many choices are there? 20. So we expect to get over 5 picks from the 5 people divided by 20. What's 25 divided by 20? I did 5 times 5 in my head, but pretty sure I know 25 divided by 20, but I'll check. It's 1.25. So we expect in any given group about 1 person, but we'll write it with the decimal. The expected number of bilingual students is about 1.25. So there's a hypergeometric distribution word problem.